Good morning, everyone. This is your teacher, Miss Rita. Today we will continue explaining lesson 1 in chapter 4, What is energy? So please open your books to page 110. Today we will explain what kinetic energy is, how to calculate kinetic energy, how potential energy transforms into kinetic energy, and we will solve some exercises. So, what is kinetic energy? In the previous video, we explained that potential energy is energy due to the position of an object. In this case, it's the opposite. It's due to the movement of the object. So when the object is moving, we can say that it has kinetic energy. Now, how does kinetic energy change? It changes with two factors. The first one is the speed of the object. For example, if a car is going fast, it means that it has more kinetic energy than a car that is going slowly. And the second factor is the mass of an object. If an object has more mass, it means that when the object is moving, it will have more kinetic energy. To understand more what kinetic energy is and when does this energy exist, let's look at this picture in front of us. In the first example, we have a tennis ball. Now the first ball is stationary, which means that it's not moving. In this case, the ball does not have kinetic energy. However, when the ball starts moving, it will have kinetic energy. In the second example, we have a gun and a bullet inside the gun. In the first example, the bullet is stationary, it's not moving, which means that it has no kinetic energy. However, when we fire the bullet, it will move and it will have kinetic energy. Now let's solve the exercises on your books. Page 110, figure 2. You have this picture in front of you. Part 1 is to list the vehicles in order of increasing kinetic energy. We said that two factors affect kinetic energy. They are the mass of the object and the speed of the object. In this case, let's start by comparing the speeds. So the red car has the highest speed, which is 30 meters per second. So it has the highest kinetic energy. So now what's left is the motorcycle and the blue car. They have the same speed, which is 20 meters per second. So I can compare their masses instead. The blue car has a bigger mass than the motorcycle, which means that it will have a higher kinetic energy. Now the question is to arrange these vehicles in order of increasing kinetic energy, which means from the smallest energy to the highest energy. So the smallest is the motorcycle, then the blue car, and finally the highest energy is the red car. Now part 2 of the question is to describe another example of two objects that have different kinetic energies and to explain why their energies are different. So here the examples can be different. I chose a plane and a bird. These two have different kinetic energies because the plane has a bigger mass and it goes faster than the bird, so it will have more kinetic energy. Since we said kinetic energy is related to the mass of an object and its speed, so we can calculate this value by multiplying half times mass times the speed to the power 2. And the answer we get is in joules. So let's apply the equation. A bike is moving and it has a speed of 40 meters per second and a mass of 13 kilograms. Calculate its kinetic energy. So to calculate the kinetic energy, we simply replace the given in the equation. We get half times 13 times 40 to the power 2. And I remind you, to the power 2, it means that here, for example, I have to multiply 40 by 40. So I get half times 13 times 1600, we get 10,400 joules. Let's solve some applications. Page 111, do the math. Please make sure to copy the answers on your books. So a girl and her dog are running. The dog has a mass of 20 kilograms and the girl has a mass of 60 kilograms. Part 1. Suppose the girl and the dog run at a speed of 2 meters per second. Calculate both of their kinetic energies. So to calculate the kinetic energies, we have to apply the equations. Let's start by the kinetic energy of the dog. We have half times mass times speed to the power 2. So we get half times 20, which is the mass of the dog, times 2 to the power 2, which is its speed. We get 40 joules. We apply the same equation for the girl, but this time the mass is 60 kilograms. We get 120 joules. Part 2. Suppose the dog speeds up and is running now at a speed of 4 meters per second. So the dog increased its speed, which means that now we should get a higher kinetic energy. Let's calculate it. We have half times the mass, which is 20, and the speed now is 4. So we have times 4 to the power 2. We get 160 joules, which is verified. When the dog increased its speed, its kinetic energy also increased from 40 joules to 160 joules. Potential energy, specifically gravitational energy, is related to the position above the ground, and this energy can transform into kinetic energy. Let's see how by following these examples. In the first picture, you have a boy biking. When the boy was on the ground, his gravitational energy was 0. He had no potential energy because he is not high above the ground. Then he started biking up, so he is moving and gaining kinetic energy until he reaches the top, where he has maximum potential energy because he is very high from the ground. Now he starts moving back down, and this potential energy will again transform into kinetic energy as he is moving down to reach the bottom. Now let's look at the second picture. The girl is holding a ball and the ball is not moving. It is high above the ground, which means that the ball has potential energy. Now the girl lets go of the ball will start moving and the potential energy will transform into kinetic energy. Now as homework, I need you to copy these following exercises on your copybooks and try to solve them. In exercise 1, you have to look at the picture, then answer the questions. Part 1, specify the point or points where the ball has no gravitational energy and maximum kinetic energy. And I remind you that a ball or an object has gravitational energy if it is high above the ground. Now part 2, specify the point where the ball has no kinetic energy and maximum gravitational potential energy. Exercise 2, a boy and a girl are running. They both have a speed of 15 meters per second. The boy has a mass of 70 kilograms, while the girl has a mass of 60 kilograms. Part 1, specify who will have a high kinetic energy. And part 2, you have to verify your answer by calculating the boy and the girl's kinetic energies. So you have to apply the equation